example 3. The number of married men in thousands between the ages of 20 and 44 in the United States is 1998 is given by the following table. So you have age ranges. You have 20 to 24, 25 to 29, 30 to 34, 35 to 39, and 40 to 44. And you have the number of men, which is, I'm not going to read them all off, but there they are. So this table is not a probability distribution. I'm going to need a probability distribution in order for me to help answer this question. So that's going to be a hint for you, because you're going to have to figure that out. Now the problem is, how do I figure out that probability distribution? Because I don't just have, ages 20 to 24, I know there's 1,332 men, but I don't know what their ages are. I don't know if how many of them are 20, 21, 22, 23, or 24. I just know that in this age group I have 1,332. So how do we get around that, or how do you think we get around that? And then again, we have numbers here. We need probabilities. When you deal with a situation where you're given, basically ranges of, scores or ages or whatever the case may be, what you need to do first is that you need to basically come up with a representative from that group. And so basically what you do is, I'm just going to average these two numbers and for each one of these. So if I average 20 and 24, I get 22. Do the same thing for 25, 29, I get 27. You kind of see the pattern at this point. So these would be the numbers I use as representatives as my X value. So I take the average age for each one of these subcategories. And of course, what I need to do is I need to total up this number here of men that were in this, data, which ends up being 27,127. And so when I set up my table here, I'm going to have my 5x values that I took by doing the averages of the minimum and maximum of each range. And then I'm just going to take these numbers and divide it by the total of those numbers to get the probabilities. So I have these. These decimals would be kind of on the nastier side as far as, being able to terminate them at a certain place or round them off. Even if you go to 4 decimal places, it may not be that super accurate if you are rounding throughout this entire thing. So you're going to see as I compute this data, I'm going to keep the fractions intact, whereas it's not 100% necessary. I'm just doing it for accuracy's sake. If you want to round it off to 4 decimal places for your probabilities, you probably find out that the answer I'm going to show and the answer you would get are very similar. So as far as the mean goes, I'm going to take each one of these and multiply it to their probabilities. So 1332 over 27,127 times 22, so forth and so on. And when I add those together, I get about 34.9456 years old. So in this study, on average, the average male in this study is about 35 years old. So they would be falling somewhere in this region right here. Not quite, but since their ages, I'd probably say more towards this age right here. And you can see that. The data, most of the data is in these last two groups, and not as much in these first three, I should say. Now, as far as the standard deviation goes, I'm going to take these same probabilities, I'm going to take these same values, but I'm going to subtract this mean from them and square it, and then of course I'm going to square root that sum. So I'm showing basically how the use of the formula, and when I figure that out, the standard deviation is about 5.938 years. So on average, 6 out of 35 is about a 17% difference. So this data seems to be deviating quite a bit, but that's mostly because I don't know what the actual ages of these men are, because they're categorized by a group. And that sometimes happens with standard deviations, is that it reflects the fact that I really don't know. Because, I can see that, as I move from age to age, just alone, I'm going by 5-year intervals here. It looks like I'm just taking 22, 27, 32, 37, and 42-year-olds for this study, but that's really not what's happening. That's the only way I can really represent the data and get a probability distribution.